Hi, my dear students. So let us revise the 15th exercise question of the 5th chapter. The question is that the bodies of masses 10 kg and 20 kg respectively, kept on a smooth horizontal surface, are tied to the ends of the light string. So you are having two bodies A and B. The mass of the first one, that is 10 kilogram, and the second one it is 20 kilogram, and they have connected each other with a string like this. Okay, so for the body B, here this is A and this is B. For this body B, the tension will act, the body B acts a tension over this string from B to A, and as well A will act a tension over the string from A to B, the tension values. Now a horizontal force F is equal to 600 Newton is applied to firstly on the A and as well B along the direction of the string. What will be the tension in the string in each case? So first of all, you are applying a force over the body B, the force F, that is a 600 Newton you are applying. So now you have to find out the net force acting over the body B and body and as well the body A. So here consider the body B first of all. For the body B, the force is applied on this direction, force, and the tension is over here in the opposite direction. And as well, if you are taking the mass as m2 for the body B, the force due to the acceleration, there is a movement on this direction, the acceleration will be in this direction. So the force over the body due to this acceleration will be in the direction of the tension, that is m2a. So by equating the tension and as well the forces in both the side, we will get, that is F is equal to m2a plus t. So we can rewrite this equation as m2a will be is equal to F minus t. But in the case of the body m1 or the body A, where only the tension and the acceleration, the force due to the acceleration, tension will be in the right hand direction, and the acceleration, the force due to the acceleration, that is for the m1, the force due to the acceleration m1a will be in the opposite direction, the left hand direction. So we can say m1a will be is equal to the tension T. Okay, so now let us see. Now two equations, you are having two equations, the equation 1 and equation 2. Now let us do the division of equation 1 by 2, that is equation 1 divided by equation 2. So left hand side, m2a divided by m1a, that is m2a divided by m1a, where a cancel, m2 by m1, which will be is equal to f minus t divided by all divided by t. So you can write this one as m2 by m1 is equal to f by t minus 1. So m2 by m1 plus 1 is equal to f by t. So you can substitute the values. So m2 by m1, m2 is 20, 10 plus 1 is equal to f 600 divided by t. F is 600 Newton. So 600 divided by t. So 3 is equal to 600 divided by t. So t will be is equal to 600 divided by 3. So here t will be is equal to 200 Newton. The tension value on the string will be is equal to 200 Newton. So if you want to find out the acceleration value, you know that m1a is equal to t. That is 10 into a is equal to 200. Hence a will be is equal to 20 meter per second. Okay. Now in the next case, you are applying the force over the body A. Instead of B, you are applying a force over the body, that is 600 Newton you are applying on the body A. So then also tension will be from A to B and B to A, and there will be an M1 M2A acts. Okay. So if you are considering the body 1, M1, the mass M1, where F is equal to M1A plus T, and as well here in the case of the body second, that is mass 2, that is M2A will be is equal to T. So rewriting the M1A, this one, rewriting this equation, M1A will be is equal to F minus T. So this equation, this one taken as 1, equation 1, and this one as 2. Divide this equation, solve the same way whatever you have followed over here. Okay, then you will obtain the tension value, and as well then you can find out the acceleration by substituting the tension value over here in this equation, that is m2a is equal to t. I think this problem or this solution is clear for you everyone. Now let us go to the fourth chapter. So by going through these exercises, we are just revising the chapters. So before going through the next part of this video, just go through the theory portion of the chapter 4, the projectile motion, that portion, and as well the equations for the motion in a plane, the kinematic equations, and you should be thorough with the kinematic equations of the linear motion. Then it will be easy in the case of the motion in a plane also. And the vector, the concept of the vector and the vector addition and all those things, we just go through those things. And now and afterwards continue the video. Exercise number 20 in the chapter 4. The question is that the position of a particle is given by r is equal to 3.0 t I cap minus 2.0 t square j cap plus 4.0 k cap. It is asked to find the velocity and acceleration. The r value you are having. So you know that v is equal to dr divided by dt. So you have to find out the d by dt of this entire vector equation. So the terms are there in t. Okay. So you can write the v is equal to d by dt of 3.0 t I cap minus 2.0 t square j cap plus 4 k cap. So d by dt of 3.0 t I cap, actually where the 3 and I cap are the constants, and only you have to find out the derivation of the d by dt of the t only. So d by dt of t, that means dt by dt. So d by dt of 3 ti, we can write the answer as 3 I cap. Okay, so d by dt of 3 t I cap will be 3 I cap. The d by dt of t will be 1 minus d by dt of 2 t square j cap is given, where 2 j cap is the constant and the t square, the d by dt of t square is actually 2t. Okay, d by dt of t square, that is d by dt of t raised to n will be is equal to n into t raised to n minus 1, n into t raised to n minus 1. So where n value it is 2, so t square 2 into t raised to 2 minus 1. So the constant value is 2 j cap, and d by dt of t square is 2 t plus 4 k cap. There is no terms of the t, so that is 4 k cap is a constant. D by dt of 4 k cap will be 0. So the v value, v is equal to 3 I cap plus 2 into 2 4 t j cap. Sorry, not plus, this will be minus. Okay, so minus. Okay, so 4t j cap, that will be the velocity vector. This is the velocity vector. And so now you are having the velocity vector. Now let us find out we have to find out the value of the acceleration, or the acceleration vector you have to find. The acceleration vector, you know that a is equal to dv by dt. So without any steps you can find out the 3i dv by dt. But the d by dt of 3i will be 0, because that is the constant. Only the term remains will be minus 40 j cap. So d by dt of minus 40 j cap will be is equal to minus 4 j cap. dt by dt will be cancelled. So d by dt of 3i will, that is 3i is a constant, so d by dt of 3i will be 0. A is equal to 0 minus d by dt of 4t j cap, where 4 j cap is the constant and d by dt of t is 1, so 4 j cap remain. So a acceleration value is minus 4 j cap. Now we have to find out the velocity value at the 2 seconds. at 2 seconds, what will be the velocity value? So the velocity value you are having is that 3 I cap minus 40 j cap. You have to substitute the value of t, that is 2, over here. So for the velocity at 2 seconds will be is equal to 3 I cap. There is no terms of t there in the x coordinate, only the constant 3 value is there. So 3 I cap minus 4 t j cap, where you have to substitute the value of t as 2, then 4 into 2 into j cap, that is 8 j cap. 8 j cap. So this is the velocity vector at the time 2 seconds. Now you are having the x coordinate and the y coordinate, that is vx and vy. In such a situation, if you want to find out the value, this is the vector equation or the vector value of the velocity. If you want to find out the magnitude, you know that v is equal to root of vx square plus vy square. So the 3 is the vx value. So v square, 3 square, that is 9 plus 64. Vy there it is 8. So 8 square or minus 8 square also, we can consider likewise also, but minus 8 into minus 8 and 8 into 8 both are 64. So that is the velocity, magnitude of velocity at 2 seconds will be is equal to v is equal to root of 73, which will be is equal to 8.5 4 meter per second. So this will be the magnitude of velocity at the time 2 seconds. Now you have to find out the direction of the velocity vector. So you can see that the 3 I cap. So 3 I cap, we can take the I cap like this, 3 I cap, and minus 8 j cap, that is the minus y direction. So minus so as you want to find out, you have to find out the sum of these vectors. Sum of these vectors is actually the 3 I cap minus 8 j cap, that is the resultant vector. So the vector addition you have to do. For that, 3 I cap, the head of the 3 I cap should be connected with the tail of the minus 8 j cap. So we are just changing the position of minus 8 j cap from here to here. Minus 8 j cap. Let me drop this one. Okay. Now the resultant vector will be this one. This is the velocity vector at 2 seconds. So now consider the angle which is made by the velocity vector with the horizontal x-axis, there is the theta. So theta will be, actually if you are considering the Pythagoras theorem, the theta will be is equal to opposite side, tan theta will be is equal to opposite side divided by the adjacent side. So tan theta will be is equal to magnitude of opposite side, that is 8, divided by adjacent side 3. So you have to find out the value of theta. So theta will be is equal to tan inverse of 8 divided by 3. Then by substituting the values, and you can solve that one, the theta value you can obtain as 69.5. 5 degree. So we can say the direction of the velocity vector v2s is making a 69.5 degree angle with the x-axis or the horizontal, and which is moving or directing downwards. So I think this question is clear for you. And remember the differentiation of the vector terms, where you have to remember this one, that one second, d divided by dt of a constant will always 0. D by dt of a constant which is multiplied with a t will be the value of the constant. Suppose d by dt of a constant into t raised to n always will be is equal to n into c into t raised to n minus 1, where you can put the value of c any constant from 0 to infinity as well, any other terms. Suppose an acceleration term also can be known. Such as any value can be the c, 3i cap, 4j cap, anything. Okay. So these identities you should remember these identities. Okay, these are important. So now let us come to the next question, that is an aircraft executes a horizontal with 18th 4.18. An aircraft executes a horizontal loop of radius 1 kilometer with a steady speed of 900 km per hour. So a circular path, the velocity value 900 km per hour, and the radius of the circular path is 1 kilometer. First of all, in this if it is given in the term of kilometer per hour and kilometer, first of all you have to convert the values into the meter per second or the meter values, where 900 meter per kilometer per hour will be is equal to 900 into 5 by 18 meter per second. So which will be is equal to 250 meter per second, and 1 kilometer the radius value. So velocity will be is equal to 250 meter per second, and radius r will be is equal to 1000 meters. Now you have to find out the value of the centripetal acceleration. Centripetal acceleration value AC will be is equal to v square by r, which is equal to 250 into 250 divided by 1000. So that is 250 by 4, that is equal to 62.5 meter per second square. So you are having the centripetal acceleration value as 62.5 meter per second square. Now you have to compare this acceleration value with the gravitational acceleration. That is the question. Compare the centripetal acceleration with the acceleration due to gravity. So simply you can take the ratio AC divided by the gravitational acceleration can be written as g, so which is equal to 62.5 divided by g value you can take as 9.8. As you are taking the ratio, the accurate value you should consider instead of taking the 10. So 9.8 you can consider. So 62 point, both are meter per second square. Okay, meter per second square. So AC by G, the ratio will be is equal to AC by, you are comparing the AC and G values. AC by G is equal to 6.37. So we can say the acceleration, the centripetal acceleration due to the motion of the aircraft was 6.37 times greater than that of the acceleration due to gravity. That will be your result. I think it is clear for you. Now the 21st question, 21, question number 21. I'll just give you some hints regarding that question and you have to find out the final answer. So the question is that a particle starts from the origin at t is equal to 0 with a velocity of 10 j meter second raised to minus 1. So 10 j cap meter second raised to minus 1 is your velocity value. Actually it is moving in xy plane and the acceleration value, it is actually acceleration vector a is equal to 8 I cap plus 2 j cap. Now the question is that at what time is the x coordinate of the particle 16 meter? So at what time the x coordinate of the particle will become 16 meter? And what is the y coordinate of the particle at that time? That is the first part of the question. And then what is the speed of the particle at that time? So three things you have to find. So here the velocity value and the acceleration values are given and initial position, that was the origin. So you can say that the R0 initial position as 0 because that is origin only. 0 I cap plus 0 j cap and 0 k cap. So now you can use the equation, that is S is equal to V0 t plus half a t square, or R minus R0. R minus R0 is equal to V0 t plus half a t square. So you have to substitute the value of here the v, this one is V0, okay, initial velocity, that is. So V0 and a value you have to substitute, and then the vector r will be is equal to V0 t ten j cap t plus half of a value, it is 8i plus 2j cap into t square. Okay, so this will be is equal to 10 j cap plus 4 I cap ten t V0 t 10 j cap into t is there, okay. So t plus 4 I cap t square plus t square j cap. Now the I cap times the j cap times 10 j cap, we can differentiate or combine the I cap and the j cap times. So 4 t square I cap will be or plus 10 t plus t square, 10 t plus t square j cap. So here, if we are considering the r is equal to xi cap plus yj cap, the x term is the 4t square and y term will be 10t plus t square. So here in this question it is given that the x term will be, or the x coordinate will be 16. So that is 4t square is equal to 16. So t square is equal to 4 and t will be is equal to 2. Now you got the value of t. So by substituting the value of t over here in the y coordinate, you can find out the y coordinate value. And afterwards, so the first portion of the question will be finished by that. Then the second part, it is what is the speed of the particle at a time at this given time. So you are having the r value here. This is your r value. You have to differentiate this r value, then you can obtain the velocity value. So differentiate this r as we have done in the previous question. Then you will get the v value and substitute the value of t that you have found here. That is the t is equal to 2. Substitute that value, then you can obtain the value of velocity. And if it is asked for the acceleration, then again that velocity vector you have to differentiate with the t, that is d by dt of v. Then you will obtain the velocity vector, the acceleration vector, and again substituting the value of t is equal to 2 seconds. Then you can find out the value of acceleration at the time it is equal to 2 seconds. Suppose if you want to find out any acceleration at some other time, that means 3 seconds, 5 seconds, likewise, then again you have to substitute the value of t as your favorable time. Here in this question it is given that is the time for the x coordinate value 16. So we found the t as 2 seconds. So we are finding the value of acceleration and as well the velocity at the time of 2 seconds. So just to try to complete this one, and some more questions we will discuss from this chapter in the next lecture. Okay, thank you.